Have you ever wondered how humans went from small groups in Africa to populating every corner of the globe? Today, we'll uncover the slow, fascinating journey of our earliest ancestors and how they shaped the world as we know it. The story of early human migration is a long, intricate, and fascinating tale that stretches back hundreds of thousands of years. It begins in Africa, widely regarded as the cradle of humanity, where our earliest ancestors first appeared. Fossil evidence indicates that species belonging to the genus Homo evolved on the African continent, and over time, they developed increasingly sophisticated tools, social structures, and survival strategies. The earliest known members of our genus, such as Homo habilis and later Homo erectus, were primarily confined to Africa for hundreds of thousands of years, but their adaptability and growing intelligence eventually set the stage for an unprecedented journey across continents. Understanding these migration patterns requires examining both the physical evidence left behind and the environmental pressures that pushed these early humans to explore new territories. Archaeological discoveries across Africa reveal a gradual progression of tool use and mobility. Early humans relied on simple stone tools to hunt, scavenge, and process food, which allowed them to survive in diverse ecological zones. The technological innovations of these early humans enabled them to exploit a wider range of environments than their predecessors. As climatic conditions fluctuated with cycles of glaciation and warming, food sources became scarce or moved to new regions. These environmental pressures often acted as catalysts for movement, encouraging groups to leave familiar territories in search of more abundant resources. Fossilized remains and ancient settlements indicate that small bands of humans began dispersing from East Africa in waves, slowly exploring neighboring regions such as the Arabian Peninsula and North Africa. These early migrations were not sudden or coordinated mass movements, but rather gradual expansions driven by necessity, curiosity, and survival. Genetic studies have provided profound insights into these ancient migrations. By analyzing mitochondrial DNA and Y chromosome markers, scientists have traced the lineage of modern humans back to a common African ancestor who lived roughly 200,000 years ago. This genetic evidence supports the notion of a primary African origin, followed by a series of migrations that led humans into Eurasia and beyond. The first significant wave of migration out of Africa is estimated to have occurred around 60,000 to 70,000 years ago. During this period, early humans crossed natural barriers, including deserts, mountains, and seas, entering regions previously uninhabited by their species. Archaeologists have found evidence of these early populations in the Levant, an area encompassing modern-day Israel, Lebanon, Jordan, and Syria. Sites such as Kafsi and Skull Caves contain fossils of anatomically modern humans, demonstrating that our ancestors had already begun venturing into new territories while retaining their African genetic roots. Environmental challenges played a significant role in shaping migration patterns. Early humans had to contend with changing climates, fluctuating water sources, and competition with other species, including large predators and other hominin populations like Neanderthals. Their ability to adapt to these challenges influenced the pace and direction of their movements. For example, periods of extreme aridity in Africa likely pushed groups to seek out regions with more reliable water and food supplies. Similarly, the retreat of glaciers in certain regions opened new migration corridors, while rising sea levels occasionally cut off access to previously accessible areas. These environmental dynamics created a complex web of push and pull factors, guiding early humans along routes that were dictated not only by geography, but also by the availability of resources and habitable landscapes. The tools and technology of early humans provide further evidence of their gradual expansion. The development of more sophisticated stone tools, hunting strategies, and eventually the use of fire allowed humans to survive in colder and more diverse climates. Archaeological sites across the Middle East and Central Asia reveal that early humans were capable of modifying their behaviors to suit new environments, which facilitated their spread across vast distances. They learned to hunt local fauna, gather edible plants, and create temporary shelters, demonstrating remarkable adaptability. The accumulation of knowledge about different ecosystems and survival techniques was likely passed down through generations, forming the basis of cultural continuity that accompanied these migrations. This gradual accumulation of knowledge and adaptation was critical for survival and ensured that human populations could persist and thrive as they moved further from their African origins. Interactions with other hominin species also shaped migration patterns. As early humans moved into Europe and Asia, they encountered Neanderthals and Denisovans, who had already been living in these regions for hundreds of thousands of years. These encounters likely involved a combination of competition, coexistence, and interbreeding. Genetic studies confirm that modern non-African populations carry small percentages of Neanderthal and Denisovan DNA, indicating that early humans not only migrated across continents, but also interacted with local populations. These interactions may have facilitated the transfer of knowledge, survival strategies, and even genetic adaptations that enhanced resilience to new environmental conditions. The presence of other hominins could have both hindered and aided the expansion of early human populations, creating a dynamic and complex migration landscape. Evidence of early human migration is not limited to fossils and DNA. Archaeological findings such as stone tools, cave paintings, and remnants of hearths provide a tangible record of human movement. For instance, tools found in India, Southeast Asia, and Australia demonstrate that humans were capable of long-distance travel, including sea crossings. The settlement of Australia, estimated to have occurred around 50,000 years ago, is particularly remarkable because it required crossing open water, suggesting early humans possessed not only the physical capability, but also the cognitive and cultural skills necessary for navigation and planning. These technological and behavioral adaptations illustrate that migration was not a haphazard process, but a deliberate response to environmental challenges and opportunities. Informed by experience and ingenuity, the pace of migration varied considerably. Some populations moved relatively quickly across new landscapes, while others remained in specific regions for millennia, gradually expanding their territory. Factors such as population density, resource availability, and environmental barriers influenced the speed and direction of movement. In some cases, harsh conditions or competition from other species slowed migration, creating isolated populations that developed unique adaptations. In other cases, abundant resources and favorable climates encouraged rapid expansion. This uneven pace of migration contributed to the diverse distribution of human populations and the development of regional variations in technology, culture, and genetic traits. Over tens of thousands of years, early human migration resulted in the global dispersion of our species. From Africa, humans spread into the Middle East, Asia, Europe, and eventually the Americas. Each wave of migration brought humans into contact with new environments, species, and challenges, shaping the trajectory of our evolution. These movements laid the foundation for the modern distribution of human populations and the remarkable diversity observed today. The story of early human migration is one of resilience, ingenuity, and adaptation, revealing how our ancestors navigated a changing world and established a presence on every continent. Through careful study of fossils, tools, DNA, and environmental evidence, scientists continue to reconstruct this incredible journey, uncovering the paths taken and the strategies employed by the first humans to leave Africa and spread across the globe. Early humans were remarkably adaptable creatures, and their survival across a variety of environments was a testament to their intelligence, ingenuity, and resourcefulness. Unlike many other species, humans were not limited to a single habitat or ecological niche. Instead, they developed strategies that allowed them to exploit an incredible range of environments, from the savannas of Africa to the frozen tundras of Europe and the dense forests of Asia. Adaptation was not instantaneous. It was a gradual process shaped by trial and error, observation, and intergenerational learning. Early humans relied on a combination of biological adaptations, behavioral innovations, and cultural knowledge to meet the challenges posed by different climates, landscapes, and ecological conditions. In Africa, where modern humans first evolved, early humans faced a mosaic of environments that included grasslands, forests, rivers, and lakes. Each of these landscapes presented distinct opportunities and challenges. The savannas, for instance, provided large herds of herbivores that could be hunted for food, but they also exposed humans to predators such as lions, leopards, and hyenas. To survive, early humans developed complex hunting strategies that often involved cooperative behavior and the use of tools. spears, sharpened sticks, and later more advanced stone implements allowed humans to hunt more effectively, increasing the chances of capturing large game without succumbing to predation themselves. Observations of animal behavior, knowledge of seasonal migrations, and an understanding of the landscape itself were critical to successful hunting, and these skills were passed down through generations, forming the foundation of cultural knowledge. In addition to hunting, early humans developed sophisticated foraging strategies. They learned to identify edible plants, roots, and tubers, as well as seasonal fruits and nuts, which provided essential nutrients during periods when meat was scarce. Knowledge of which plants were safe to eat, how to process them, and where to find them required careful observation and memory, creating a link between survival and learning. Early humans also utilized water sources effectively, recognizing the importance of rivers, lakes, and other freshwater sources for both drinking and hunting. The ability to locate and exploit these resources was a crucial component of survival and shaped the movement of populations across the landscape. As humans began to move beyond Africa, they encountered environments that were vastly different from the ones in which they had evolved. In the Middle East and the Levant, for example, early humans experienced a combination of arid deserts and fertile river valleys. Adaptation to these new conditions required modifications in subsistence strategies, settlement patterns, and tool use. Stone tools became more specialized, reflecting the demands of hunting different species and processing new types of food. Humans also developed temporary shelters and utilized caves to provide protection from extreme weather and predators. Fire played a central role in adaptation, providing warmth, protection, and a means to cook food, which not only made it safer to eat, but also increased its nutritional value. The controlled use of fire demonstrates the ingenuity of early humans and their ability to manipulate their environment to meet basic survival needs. In Asia, early humans faced dense forests, high mountains, and extreme climates that tested their adaptability. Populations moving into these regions had to cope with new animal species, unfamiliar vegetation, and varying seasonal conditions. Clothing and shelter became increasingly important as humans needed to protect themselves from cold, wet, or otherwise harsh conditions. Early humans likely used animal hides, furs, and plant materials to create protective coverings and construct shelters. These innovations were not only practical, but also required careful planning, coordination, and skill, reflecting the growing complexity of human behavior and social organization. Adaptation in these environments was not only a matter of survival, but also of innovation, as humans experimented with new technologies and strategies to thrive in diverse ecological niches. Behavioral flexibility was a key component of adaptation. Early humans were not rigid in their habits, they were capable of modifying their strategies in response to changing conditions. For example, during periods of drought or food scarcity, populations would adjust their diets, expand their foraging range, or migrate to more favorable regions. Observational learning and social transmission of knowledge allowed humans to quickly adopt successful strategies from other groups. Cooperation and communication were critical to these adaptive behaviors, as individuals who worked together were more likely to survive and pass on their genes. The development of language, or at least sophisticated forms of communication, would have enhanced the ability of groups to coordinate hunting, share knowledge about resources, and transmit survival skills, further improving their chances of thriving in challenging environments. The spread of humans into Europe introduced entirely new challenges. The continent was home to Neanderthals, who had already adapted to cold climates over hundreds of thousands of years. Early modern humans moving into these regions had to contend not only with unfamiliar weather conditions, but also with competition for resources. Clothing, fire, and shelter were essential for surviving the cold winters, and evidence suggests that early humans developed tailored clothing and insulated shelters to cope with these conditions. Hunting strategies also evolved, as humans had to pursue species adapted to colder climates, such as reindeer, bison, and mammoths. Cooperation within groups, careful planning, and innovation were critical for successfully hunting these large animals, and the resulting social structures likely reinforced bonds within communities and promoted cultural continuity. In addition to physical adaptations, early humans exhibited remarkable cognitive flexibility. They were capable of abstract thinking, problem solving, and planning for future needs, which allowed them to anticipate seasonal changes, store food, and prepare for environmental challenges. Foraging strategies often required careful timing, knowledge of plant cycles, and an understanding of animal behavior. Tool use became increasingly sophisticated, with the development of composite tools, blades, and other specialized implements that enhanced efficiency and effectiveness. This combination of cognitive, technological, and social adaptations enabled humans to colonize regions that would have been impossible to inhabit without such ingenuity. The use of fire, clothing, and shelter represents a broader pattern of niche construction, whereby humans actively modified their environment to make it more habitable. Unlike other species that were forced to adapt solely through biological evolution, humans were able to create solutions that bypassed some of the limitations imposed by natural selection. By controlling fire, humans could cook food, stay warm, ward off predators, and modify landscapes. By creating clothing and shelters, they could survive in climates far colder or more variable than those in which they had evolved. These innovations reflect the unique combination of intelligence, creativity, and social cooperation that characterized early human populations and set them apart from other species. Interactions with other hominins also influenced adaptation strategies. In regions where Neanderthals or Denisovans were present, early modern humans may have exchanged knowledge, competed for resources, or interbred, leading to the transfer of genetic adaptations that enhanced survival in particular environments. For instance, certain genetic traits associated with cold tolerance in modern humans are thought to have been inherited from Neanderthals, demonstrating the impact of inter-species interactions on adaptation. Such exchanges highlight the complexity of human survival strategies and the multiple factors that shaped the ability of early humans to thrive in diverse environments. Early humans also demonstrated remarkable flexibility in diet, which was a critical component of their adaptability. They were omnivorous, able to consume a wide range of foods depending on availability. In some regions, this meant focusing on hunting large game. In others, it meant gathering plants, fish, or shellfish. Evidence from archaeological sites suggests that humans were capable of shifting their diets seasonally and opportunistically, exploiting whatever resources were accessible. This dietary flexibility reduced vulnerability to environmental changes and allowed humans to occupy regions that might otherwise have been inhospitable. Knowledge of edible and medicinal plants, methods for food preservation, and techniques for processing different types of food all contributed to the survival and expansion of early human populations. Over thousands of years, these adaptations accumulated, creating populations that were increasingly resilient to environmental stresses. Groups learned to combine technological innovation, social cooperation, and behavioral flexibility to survive in virtually every ecological niche they encountered. From African savannas to Asian forests, from European tundras to Australian coasts, early humans demonstrated an unparalleled ability to adjust to diverse environments. Their strategies were not static but dynamic, constantly evolving in response to changing conditions, new challenges, and accumulated knowledge. Each successful adaptation allowed humans to push further into previously uninhabited regions, gradually laying the groundwork for the global spread of our species. The movement of early humans across the globe had profound and lasting effects on the distribution, diversity, and development of human populations. Unlike other species whose range is largely determined by biological constraints, early humans expanded through a combination of intelligence, adaptability, and social cooperation. This dispersal not only shaped the geographic patterns of settlement, but also influenced genetic variation, cultural development, and interactions with other hominin species. Understanding the impact of these movements requires a careful examination of archaeological evidence, genetic studies, and the environmental and social contexts that influenced human expansion. One of the most immediate impacts of early human movement was the establishment of populations in previously uninhabited regions. Africa, as the origin of modern humans, initially hosted a variety of hominin species and early Homo sapiens populations. As groups began migrating out of Africa around 60,000 to 70,000 years ago, they spread into the Middle East, Asia, Europe, and eventually the Americas. Each migration resulted in the formation of new populations, each adapting to local environmental conditions. This expansion allowed humans to occupy a wide variety of ecological niches, from the tropical forests of Southeast Asia to the Arctic tundras of Northern Europe, demonstrating the species' remarkable flexibility and resilience. The dispersal of humans led to the development of regional differences in both physical traits and genetic makeup. As populations settled in diverse environments, they underwent natural selection that favored traits advantageous for survival in those specific regions. For instance, populations in northern latitudes developed lighter skin pigmentation over generations to facilitate vitamin D synthesis in areas with lower sunlight exposure, while populations in equatorial regions retained darker skin for protection against ultraviolet radiation. Similarly, adaptations to diet, altitude, and disease resistance varied among populations depending on local conditions. These differences illustrate how migration and settlement in new regions directly influenced the evolution of distinct physical characteristics among human groups. Genetic studies provide a window into how early migrations shaped the modern human gene pool. Mitochondrial DNA, which is passed from mother to child, has been used to trace maternal lineages and confirm the African origins of all modern humans. Analysis of Y chromosome DNA, inherited paternally, complements this by tracing male lineages. These studies reveal that as humans spread across continents, they carried with them a subset of the genetic diversity found in their ancestral African populations. Bottlenecks, founder effects, and isolation in remote regions further shaped genetic diversity, leading to the unique distribution patterns observed in modern populations. For example, populations that migrated into the Americas carried only a fraction of the genetic diversity present in East Asian populations, reflecting the small number of individuals involved in these early migrations and the long-term effects of geographic isolation. The movement of humans also had significant cultural implications. As groups migrated, they carried with them knowledge, skills, and technologies that were critical for survival. Stone tool technologies, for instance, spread along migration routes, with local adaptations emerging based on available resources and environmental challenges. Similarly, knowledge about fire, hunting techniques, and foraging strategies was transmitted from one generation to the next and from one group to another. This transfer of cultural knowledge not only enhanced survival, but also fostered the development of increasingly complex social structures, cooperative behavior, and communication systems. The spread of early humans thus created a foundation for cultural diversity, with regional variations in technology, art, and behavior emerging over time. Interactions with other hominin species significantly shaped the impact of human movement on global populations. As early modern humans moved into Europe and Asia, they encountered Neanderthals and Denisovans, who had been living in these regions for hundreds of thousands of years. Genetic evidence shows that interbreeding occurred, resulting in the incorporation of Neanderthal and Denisovan DNA into the modern human genome. These interactions may have conferred adaptive advantages, such as increased immunity to certain pathogens or enhanced physiological traits suitable for cold climates. The presence of other hominins also created competitive pressures that influenced migration patterns, as humans sought territories with abundant resources and minimal competition. In some regions, coexistence and cultural exchange may have occurred, allowing for the sharing of knowledge and survival strategies that enriched the adaptive capacity of migrating populations. The migration of humans into the Americas is a particularly striking example of the global impact of early movement. Populations crossing from Siberia into Alaska via the Bering Land Bridge around 15,000 to 20,000 years ago initiated the settlement of a vast and diverse continent. This migration led to the formation of numerous distinct populations, each adapting to a wide range of environments, from Arctic tundra to tropical forests. Archaeological sites throughout North and South America reveal variations in tool technology, subsistence strategies, and settlement patterns, reflecting the influence of local conditions on cultural and physical adaptation. The migration into the Americas demonstrates how early human movement shaped population distribution, on a continental scale and contributed to the rich diversity of human experience observed today. Migration also influenced population density and social organization. As humans spread into new regions, they often encountered abundant resources that allowed populations to grow, settle, and form larger, more complex social structures. In some cases, environmental constraints limited population growth, creating small, isolated communities that maintained unique cultural and genetic traits. Over time, migration facilitated contact between populations, leading to the exchange of ideas, technologies, and genetic material. These interactions contributed to the interconnectedness of human populations and the gradual emergence of broader networks of cultural and genetic exchange. The global movement of humans thus played a central role in shaping not only where humans lived, but also how societies developed and interacted over millennia. The dispersal of humans also had long-term ecological impacts. As humans entered new environments, they affected local ecosystems through hunting, foraging, and the use of fire. Large mammals in particular were impacted by human predation, leading in some cases to extinctions or significant population declines. The introduction of human activity into previously untouched environments altered plant and animal communities and set the stage for future ecological interactions. This influence was not limited to immediate environmental effects, but also shaped the evolutionary trajectories of other species, demonstrating the profound impact of early human movement on global ecosystems. Early human migration influenced linguistic, artistic, and cultural diversity. As populations became geographically separated, distinct languages, artistic traditions, and social practices developed. The isolation of groups encouraged innovation and the creation of unique cultural expressions, while contact between populations facilitated the sharing of ideas and practices. Rock art, carvings, and symbolic artifacts found in different regions reflect both the creativity of early humans and the influence of migration on cultural development. These expressions of human ingenuity provide insight into how migration shaped not only physical and genetic diversity, but also the richness of human culture across the globe. The long-term consequences of early human movement are evident in the distribution of modern populations. Populations in Africa retain the highest levels of genetic diversity, reflecting the continent's role as the origin of modern humans and the long-term continuity of populations there. Populations in other regions exhibit varying levels of diversity based on the timing, size, and routes of migration. The patterns of genetic variation observed today are the result of a complex interplay of migration, isolation, adaptation, and interaction with other hominins. By studying these patterns, scientists can reconstruct the paths taken by early humans and gain insight into the processes that shaped the human species. Migration also fostered technological innovation and cultural transmission on a global scale. The movement of humans exposed populations to new challenges and opportunities, driving the development of tools, social strategies, and survival techniques. Populations adapted technologies to local conditions, creating regional variations that enhanced efficiency and effectiveness. Knowledge of hunting techniques, food processing, and environmental management spread along migration routes, creating networks of shared cultural practices. The cumulative effect of these innovations was the establishment of a foundation for the development of increasingly complex societies. As humans learned to manipulate their environments, cooperate in larger groups, and transmit knowledge across generations. The spread of humans across the globe was not a uniform process. Some regions were colonized rapidly, while others were settled gradually over thousands of years. Environmental barriers, such as deserts, mountains, and seas, shaped the routes and timing of migration. Populations often followed rivers, coastlines, and resource-rich corridors, creating pathways that facilitated movement while minimizing risk. The uneven pace of migration contributed to the development of isolated populations, which in turn allowed for regional adaptations and cultural differentiation. These patterns of settlement illustrate the dynamic relationship between human movement and environmental factors, highlighting the complexity of global population distribution. As humans spread across continents, they influenced the genetic, cultural, and social landscape of the world. Migration facilitated the mixing of populations, the exchange of ideas, and the development of diverse adaptations that enabled survival in a wide range of environments. The movement of early humans laid the foundation for the interconnected global population we observe today, with genetic lineages, cultural practices, and technological innovations tracing back to these initial dispersals. By studying the impact of migration, researchers can better understand the processes that shaped human evolution, the spread of culture, and the establishment of populations across the globe. The global impact of early human movement also extends to the understanding of human resilience and adaptability. Populations that faced harsh climates, scarce resources, and competition from other species developed strategies to cope with these challenges, often creating solutions that would influence subsequent generations. The cumulative knowledge acquired through migration about food, shelter, social organization, and environmental management enhanced the survival prospects of humans in every new region they encountered. Migration was thus a catalyst for innovation, adaptation, and the emergence of complex behaviors that defined the trajectory of the human species.